Hey AP students, good morning. Happy Wednesday. Happy Motivational Wednesday. I definitely think you should check out the Motivational Wednesday video. As some of you know, I've been working on a puzzle, a measly 1,500 piece puzzle, but it's making me work. And there's a video of a guy, it's a time-lapse video of a guy completing like a something thousand piece puzzle. And his strategy is really, really interesting. And pay attention to his, like how many times he changes his clothes. That gives you kind of an idea how many days it took. All right, this is gonna be our last video on this topic, on matched pairs. Remember, you have a quiz on Friday, and just a heads up, the quiz on Friday, I'm thinking of making like the AP test where you submit your questions you have one question and then you submit that and you have another question. And I'm thinking about doing it at 11 a.m. So if you're not used to waking up at 11 a.m., get used to it or be ready that day, okay? If you miss it, you miss it, okay? There'll be no makeups. So I just want to go review a little bit about what the difference is between these three different types of tests. So this was chapter 25, our current chapter 24, and then chapter 23 here. So obviously with one sample mean, you just have one population. I also want to go over just some of the other like names that it goes by, aka it might be the difference in two means. Another aka for matched pairs, if you guys remember from our last video, is paired data or mean difference. Okay? And again, is mean difference different than the phrase difference in two means? Okay, so think about that. For one sample mean, obviously there's just one population. For two sample means, you have two independent populations. Okay, so that's key. The two groups are independent of one another. And for matched pairs, you have two dependent populations. Okay, so key difference, independent and dependent. For your test here, the calculator command, you're using the second one, the t-test, and you are also using t-test for matched pairs. So matched pairs is basically a one sample mean because you're doing a one sample mean on the means, the mean difference. And then this one was option 4, the two sample t-test. So that's just a brief summary of the difference. Okay? All right. So the example I want to go over today has to do with exercise. I hope you guys are all exercising during this time somehow, whether it be in your room, T25, ab ripper, CrossFit, whatever you got, or simply taking a walk around the block. Okay, please keep the heart rate going. So what I wanted to talk to you about is, if you want to pause the video, you can copy this down. You could read through it. I'm just going to read it out loud right now. Exercise increasing your heart rate is a good way of staying healthy, especially during this time. Mr. Fukao wants to investigate whether exercise really increases your heart rate. In Monday's video, Mr. Fukao asks for volunteers to submit the number of heartbeats per 30 seconds while resting, and then also after doing 20 jumping jacks. The following table shows the collected data. Is there evidence that heart rates increase immediately after exercise? So if you think about this, you're probably thinking, duh, right? Like after every time, even like when you're coming to class, to my class, when you walk up those stairs, your heart rate jumps a little bit. So common thing would be like, yeah, of course. But we are looking at the word increase, okay? So that should tell you something about our alternative hypothesis. Okay? So volunteers, I believe we had 17 volunteers. 17 of you submitted your data. And here's a table of the 17 of you. If this is difficult to read, just know that this side, okay? And then this is the continuation of that side, okay? All right. So copy this down right now, or you can, maybe I'll post it on Google Classroom as well. okay? So when you input these, you're gonna be inputting these in a second, but this is your L1 and this is your L2. L1, L2, okay? Oh, by the way, some of you, when you submitted your data, I think you counted beats per minute, not beats per 30 seconds. So for some of your heart rates that were kind of high, I just made a non-medical professional assumption that you gave me per 60 seconds rather than 30 seconds. So I just cut that in half. Okay, and one of you, I think, misread or misheard on the video. On the video, I said just to do, I told you guys to do, yeah, beats per 30 seconds, and I think someone did like jumping jacks per 30 seconds. So that, you know, that's a cause of concern. All right. All right, so let's take a look at this data. So we have to first define our variables, right? So let's define what mu, we'll use before and after again. So mu sub b stands for true mean of beats per 30 seconds while resting. Okay. Mu sub a is the true mean of, do you guys hear that screaming? That's a screaming cry of a child who wants to come out of bed, but I'm not letting them. After 20, can I just write JJ? After 20 jumping jacks. Okay, so now your difference, mu difference, is the true mean difference of heartbeats or pulse rates, beats per 30 seconds of after 20 jumping jacks minus resting. Okay, so this part is key right here, because if you flip these two around, so this would give you a positive value, right? Like most likely your heart rate increases. So this would be positive, but if you switch these two, it would be negative. So your null in this case, you can abbreviate this as D as well. Okay, if you don't want to write DIFF, is equal to 0. That means there's no difference, right? So A equals difference is greater than 0. Okay. Why is it greater than? Because if you remember, if in a given information it says heart rates increase. Oh, and also keep in mind how I collected my data. We're going to talk about this at the end of this question. Okay, does that tell us anything about this experiment or observational study? Which one is it? All right, so now let's check our conditions. So first thing we need to check is we need to check NIR. Hi, good morning, buddy. Good morning. Okay. Okay, so we have to check our histograms. So I'm just going to sketch those. So I'm going to do a before and an after. So remember, take your calculator, and the first thing you need to do is in your lists, I already went ahead and did this, but in your L1, input all of your heart rates before. Okay, so starting with 35, there should be 17 total values. So input those. Pause the video while you do that. And you can also do your L2. And let's pretend I did not do my L3 yet. Okay, so go ahead and input those right now. All right, so then I'm gonna go to second stat plot, and I'm gonna take a look at, oops, I wanna do my, where am I going? Stat, edit. Right here, I wanna go to L2 minus your L1. Okay, if you're wondering why it's L2 minus L1, Remember we decided that it was 20 jumping jacks minus resting. And this is your L2 minus your L1 right there. Okay, hit enter. And if you want to just double check, right, you can see that 50 minus 35 is 15. 56 minus 41 is 15. Okay, let's take a look. Who had the biggest difference? 27, 44. Well, okay, etc. 5, that's pretty low. 38. All right, so we're gonna go to second, stat plot, and then you want to turn it on. If it wasn't on, go to the histogram option, and in your list we're using L3, right? We're using the mean difference. So I'm gonna go to graph. Where's my graph? Zoom 9, okay? So we are not gonna use this before and after here. I'm just gonna get a new sheet of paper. Okay. So I'm just gonna sketch my histogram. It does not have to be exact. You don't even need a ruler. Surprise, surprise. Okay, it looks kind of like this, right? So although the histogram of differences is not normal, we will assume it to be so. Now independence right here, we assume each volunteer is independent. And in class, I noticed something interesting. If you look at the people who submitted their data, I noticed that they're, oops, where's that? There's a higher number of females who submitted their data, which is understandable because we have a higher number of females in AP statistics. But I noticed a lot of you are like friends, so I wonder if like one of you saw the video and then you told your friend to go watch the video or at least submit the data. So obviously you guys are not independent, right? However, that's okay. We're just gonna assume that they are. And we know for sure you were not randomly chosen or randomly assigned to do this because you volunteered yourself and you had to have watched the video and you had to have had internet to watch the video and you have to have been awake and coherent to watch the video and you have to have cared about AP stats and your AP stats grade and not given up on life yet to watch the video and submit your data. Okay? So we're just gonna, we assume each volunteer was randomly chosen, okay? And we assume that 17 volunteers is less than or equal to 10% of the population. So the population is unclear. Are we talking about like the world in general, like all people? Are we talking about just Marshall students? Are we just talking about AP Stat students? We don't know, so we're just gonna say 10% of the population, whatever that is, okay? So the test here we're using is the matched pairs t-test, right? We always use t for mean, z is for proportions. Our alpha, we'll use a 0.05. Do you want to be dangerous? Do you want to live life on the edge and try something different this time? Nah. And then tails, since it's greater than, right? Our alternative was greater than, so it's going to be 1 upper tail. Okay. So now for our calculations, we're going to go to stat, test, t-test, 2t-test. And class, should we use data or statistics here? We're going to use data. And our null mu null is going to be 0, list 3, frequency 1, and then it's greater than, right? So we're going to calculate, but I'm also going to draw it too, to draw a nice normal curve. And as you guessed, okay, our p-value is close to 0. It's like way over here, all right? Our mean difference, if you go back to test, and then you go to calculate instead, remember this value is 0. Our difference is 0. However, our mean is 21.18. So that's the average difference of the 17 individuals who submitted their data. So our t-score right here, how many standard deviations do you think it's above? Well, it's saying is 8.80. Okay, that's way far away from the mean. That's almost 9 standard deviations away. And our p-value, you guessed it, was really small. Now, please don't make the mistake of writing this. P-value, P stands for probability. Probability cannot be greater than 1, right? So it's minuscule. All right, so now let's write our conclusion. Since our p-value of 7.93 times 10 to the negative 8 is far less than our alpha of 0.05, we surely reject the null. Okay, we do have evidence. Okay, now I'm going to get my, I'm basically going to copy this statement right here. Okay. Do have evidence that the true mean difference in beats per 30 seconds of after minus before is greater than 0. Okay? Sorry this is so sloppy today. Right, doesn't that totally make sense though? Right, like we all know, or we all think we know, that your heart rate increases after exercise, during exercise. This answers a few more questions. So, was this an experiment or an observational study? Remember, observational study is you're simply looking at data. You're not manipulating, you're not controlling, you are not assigning, you are just simply watching. Okay? You can go back and collect data, which is retrospective study. You can go and collect data from here on out, which is prospective observational studies. So this case, it's simply an experiment. Why is it an experiment? Because I told you what to do. I said you had to take your pulse, right, while resting, and then do 20 jumping jacks, and then test it again, or count it again. I controlled that, right? And only people who watch my video could do it. So evaluate the design of the experiment. What could have been improved? So like I already mentioned that, you needed YouTube to watch this, and the responses that I got, all of you are like 17 to 18 years old. So that must mean something. And maybe the time of the day influences your beats before. Or let's see, maybe what you just ate. Maybe some of you had a sugary Pop-Tart right before. Maybe if you just woke up. Maybe some of you you went on a 18-mile run right now, and then you tested your heart rate, and then you did 20 jumping jacks. Some of you didn't even follow directions, right? Some of you did jumping jacks for 30 seconds. So those are all quote-unquote flaws. Now those are things that in an actual hypothesis test, you would explain that in this section. You would say that some people didn't follow directions. So you have some choices. You can throw out the data. The individuals who did not follow directions, you can throw them out. Oh yeah, that's right. I also made an assumption because some of you gave me beats per 60 seconds. I assumed like some of your resting heart rates were like 90s. So I cut that in half because I just assumed that you meant half of that. Right? So many ways it could be improved. Is this test statistically significant? Do you guys remember that terminology? It came, gosh, I want to say chapter 22, maybe chapter 22. If your p value is less than your alpha, so basically if you reject the null hypothesis, we say yes, it is statistically significant. Okay, so in this case, yes it is. And remember this question about type 1, type 2 errors? If we did make an error in this case, what type of error could we have made? We're not saying we made an error, but if we had, right? We concluded to reject, we rejected the null, right? So that means the only type of error we can make is type 1, right? There you go. Okay guys, thanks for watching this video. See you later.